Again, thank you for coming. Today we are going to talk about Android quality, Android performance, and Android stability, about all the aspects of well-written application, about well-designed atmosphere of a team. So it's not only about product itself, but also about development. And we will be talking about different tools which we actually used in our past, and some of them we like, some of them we don't, and I will just do like overview of what we have done, what we have tried, and you will have chance to see actually what you need or what you can try in your projects. So let's start with this overview. The first section is about quality tools. It's mostly static analysis tools, but it's not only. It's also some other things like check style for how code looks actually, but not how it performs, and about some other things, and also some developer tools which you can actually see, just get an idea how it works, what does it mean, and do you want it or do you need it actually or not. So let's start with them. The first one is lint. It's actually quite common and quite useful. I think every Android developer knows it. Actually, how many of you know lint? Yeah, perfect. It's actually what I expected. Nice. So I'm not going to talk a lot about it. The first thing, it's going out of the box. So it's already shipped into Android SDK. You don't need to put much effort to configure it. It's already in. It's actually what makes it unique, because some other things you need to configure, you need to spend time. It's Android specific. It's also unique for lint, because it can find some really Android related things which are typical only for Android development. It has more than 200 different checks out of the box, so you can just grab them and use them. You don't need to write any extra code on top of it, at least for the first time. It has Android Studio integration, so it is already in your IDE, so you can just see how it works when you write code. It's fully configurable, so if you don't like some of the rules, you can just ignore them. It's also, I think, clear. Yeah, it has lint baseline, which is something interesting, and we will talk about it a little bit later. And it has custom rules, so you can write some custom rules. Actually, I'm not going deep into these things. There was one really good talk about lint custom rules and about how you can configure lint. You may see actually recording later. I think it was Nikolai Nesterov. Yeah, am I right? Okay, it was pretty useful tool about lint. So I'm not going to talk much about that. Just when video is available, you can check it and see. Okay, so let's see how actually it works. Most of the time, at least it was before, I don't know how it's now, but I often faced with the problem that lint was disabled in a project, and it's not a good approach. Lint is actually developed to help you, not to annoy you or to do some problems for you. It's actually something we have to use to make our code better, to make product better. And the right way of using it, it's not disabling it, but enabling some rules or disabling some other rules to make like exceptions. And this is the base implementation of how it may be added. It also may be extracted into separate file if you don't want to make your file like really big. And that's why it can be just moved to another place. But this is just basic representation, so you know how it looks. And it has many different checks out of the box, as I previously said. For instance, missing super call. If you, in your implementation, need to call super call because there is some kind of functionality in parent class, you need to annotate it with call super, and lint will actually raise a warning or error. It depends on your configuration that you have some wrong implementation. And there are many really useful out of the box, as I already said, rules which may be useful in your projects. Here is like most useful or really common one. Let me stay here. So how it actually works? It's also, as I said, has Android Studio integration. And when you write code, you actually see the warning immediately. You don't need even to run your code. You will see it. It also integrated with IDE rules because there are many on top of them. So it will just show you the point where you did a mistake in your code. And just another one. But what always happens, you may have a legacy project which you have, I don't know, since 10 years ago. Yeah, it's not in Android, of course, like since 5 years ago, okay. And you want to add lint, and you will have like thousands of issues already in, and it's a pain, and it's actually what may prevent you from adding lint to your project. But there is a solution called lint baseline, and what it does, it actually skips existing issues. It checks only new ones which may be added during the development, and it still shows you the baseline warning. What for? Because you don't want to leave that warnings in your project forever. The main goal is to finally fix them, but you will see this annoying warning about there is something still need to be solved, but it will not fail the build. And this is how it works. You just add one line called baseline file, and for the first time, Gradle plugin will generate a baseline file which be used later to use this rule set. And this is how your build will be, your output of build or lint debug will be if you don't have a lint baseline. But imagine we have 3 warnings in our baseline, so you will see this warning, as I mentioned, which says you still have some issues which are filtered because of baseline. Okay, go next. There is many of tools. We are going to talk about measure ones, which we tried and which we think are actually useful. The next one is Infer. Infer is developed by Facebook. It's quite powerful and quite intelligent. It has not just simple analysis, it has advanced analysis which called interprocedural, which means it not just checks the code in one file, it checks dependencies between different models, between different method calls, between different classes, which is quite not trivial task, I would say, but Infer and actually Facebook developers achieve this goal, and they can actually check in like dependencies between different procedures and between different objects. It's really easy to install, which is also not good for some tools, which I will be mentioning later, because some of them it's quite required some time to install it initially. Yes, and it's also not only Java. Unfortunately, it's not Kotlin, but it supports also Objective-C and C++, which is maybe used for other languages as well. Actually, I'm going to talk about some tools which are also compatible with other languages. And the main implementation actually contains just command line implementation, but there are some not official plugins which you can use if you want to just plug in into your build process as a plugin. How it works. It just takes the code. I mean Infer, of course. It passes it to build system, and build system actually communicate with Infer with output, which is analyzed by Infer, and Infer builds like a dependency tree, and based on that dependency, it's like own format in Infer. They provide you all the issues they actually may find or they found. And how it works. As I said, it's really easy to install. On Mac, you can just call brew install Infer. Then now it's Android thing, because before it was more like general. You clean your project because you want to build to see the output, the real issues, and then you just run. Actually, these 3 dots, which you can see here, it's not just dots. Actually, Infer will print you how many methods and how many classes you have in your project, and it's like full of dots and Fs, which mean it's a method or it's a file. And after some time, it may take like minutes, you will have the list of issues which Infer found. And there are some of them. Actually, the main types are resource leak, which mean there is something like cursor or whatever input stream, which is not closed. Another thing which is checked by Infer is null difference. Null difference. And when you will not have this problem in Kotlin, but in Java you may still have it. And if you pass null from one thing, from one method, and another method doesn't really check for a null, even if you do not annotate it with nullable or non-nullable annotation, I would say this one is really useful for legacy projects, because you can find that null pointers for which actually happening, but you will find them just after one run. And context leak, which is just leak of context, which is, I think, trivial problem for Android developers. And this is, for instance, the example of how Infer checks and shows the errors. Just check the code. So we just print the piece of code and show that it is an issue, because I don't mention that dir is null or not null, but there is another call where I'm calling this method, and I actually may pass null here. Find bugs. This one is a Java bytecode analysis tool, which may analyze Java bytecode. This is not as intelligent as the previous one, because it's actually designed to analyze Java code, but it's still useful. It still may find good, not good, but bad things in your projects. It may find some things you can optimize and can implement. It has Android Studio plugin, which you can also integrate into Android Studio and see issues in IDE. And it requires some time to configure initially, because, as I said, it's designed to be a Java plugin. And it is how it actually looks in your Gradle file. It may be a different file. It may be your main file, but we extracted everything into a quality package, as we called it. And this is how your basic implementation would look like. So, for instance, we have this sample of code. Does anybody may point for a small issue we have here? No. Yeah, maybe. Yeah. Do you see another one? Yeah. Yes, exactly. So we may have here the situation when we iterate, and we will create every time a new string builder. Actually, not we, but compiler will create. And after going through this loop, we will have as many objects as we have items in our field, which is extra objects, which is not what we want to have. So findBug will point that there is an issue. And how we should implement it, it's like this. We should have a string builder. We should append a field on every iteration. And this is an example of warning which findBug will show us. Here are some examples. Yeah, there are many of them, but just some more obvious. Like string comparison with two equal symbols, but instead of calling equals method, like method invokes to string on a string, test for floating point equality, and so on. PMD. This is another one, quality tool, static analysis tool, which is designed to analyze Java code. It's designed to analyze Java source code. It's also required some time, as I said, for findBug. It also applies here, that it requires some time to configure it. And because of different way of analysis, it actually may find another issues, because it actually checks source code, but not bytecode, for instance, how findBug does. And this is, again, the piece of Gradle file, how we can actually add it in. I don't know, is it visible because I'm always standing here? OK. Yeah, so how it would look. And there is one good rule in PMD which I like. Actually, this is maybe a main point why we have it in our projects. It's called God class. There are some analyses which may analyze your code and say that one class has too many responsibilities or too many dependencies, or it does too many things. And there are some algorithms to analyze that. And it's actually this rule in PMD called God class. And by it, I mean PMD can find and trigger that issue. And there are many other things. Some actually of them are Android related, like the second one, do not hard code SD card, but this issue is completely covered by lint, for instance. Actually, there are some overlaps on these tools, so you need to think which one you want to use, which one you don't. But apparently they do similar things, but with different rules. And it doesn't mean that you should use only one or you should use all of them. It's up to you. It's just you need to try it and see the outcome. Check style. This one is about actually the style of your code. It's not about how it performs, but it's how it looks. And it has checks to check class and method diagram problems. It also may find code layout issues and formatting issues. To add it to your project, you need to add next lines to your build file. Again, some configuration inside of task. And yeah, that's it. Here is actually on this slide, you can see that it has a config file. And config file actually has a set of all rules you want to check. This is the file. So we, in this case, checking for tab characters in files, which means we don't use tabs in our style. We also have tree walker tree, which means it will iterate through all the classes and all the instances we have, and it checks for names of variables, of constants, and it does many different checks inside, line lengths, method lengths, and other things. You can also define some parameters for instance, in this case, it's for line length, but it may be, you need to check the documentation, but you may customize almost all of them. Copy-paste detector. This is one of my favorite ones, because if you have multiple developers in your team, it's more likely that you have some copy-pasted code from maybe previous projects or from Stack Overflow or whatever. I don't know from where you copy your code. Yeah, and unfortunately, sometimes it's a problem, because if one piece of code contains issue and you copy it to 5 places, you have 5 issues. And again, it makes your code base bigger, but apparently you do not have bigger code. You just have bigger amount of files. So it's just about amount, but not about knowledge or about some usable code. And it ignores, it doesn't analyze imports and copyrights, which you usually have at the beginning of each file. So it's kind of smart. It does actually smart analysis. It's not just compares two classes, but it also compares in a smart way. So it skips white spaces, it skips many things you don't actually care about. So it really checks how your code performs. And it may be integrated into your build process or check process, or it may be run as a standalone tool. For instance, you want just to check how it will it find something on existing project or not. And it has support for many languages. Yeah, it's really, the list of quite big. You can also add it to your build file, but there is no really one plugin. I just found one which we use for a long time already, which is not popular. I don't know why, but it's quite stable and good. And how it will work, you can just run copy-paste detector check, and it says that you have some duplications, and output the path where you can find what actual duplications and which files and what piece of code. And later you can decide, is it like should be, or maybe it is, I don't know, need to be fixed, can be extracted to another place. But anyway, it just says that you have an issue. How you fix it, it's up to you. Strict mode. It's not about static code analysis tool, but it's about tool mode of your application, which you may enable in develop. It's mode which helps you to find problems with INRs when you do some background operations in UI thread, like writing to file system or reading from file system. When you do some other operations, like not really expected one, we will see example later. And you can actually find these issues before going live. So during development, you will see that, okay, I have some issues here, because you define a penalty for every issue. And it should be debug only, because you don't want to crash release app because it does something wrong. And it has flexibility and penalties. So here is the example of what can be defined. So we, for instance, want to check disk reads, disk writes, networks, and we want to define penalty, which means we will just write to log some incorrect disk operations or network operations in the main thread. And same for leaked resources. It's covered by another quality tools, so you always can think which one you would like to use or which one you don't. So there are so many tools, which one should I use? This is a really common question, which one should I, and maybe I don't need them at all. We have a rule, it's not a rule, it's like rule set, which one we use in our projects, and it looks like this. Lint, it should be always, because it coming out of the box, you don't need to spend much time, just some, maybe few exceptions, and it will work perfectly. Strict mode, yeah, if possible, yes, because it's coming out of the box, enable it and just enjoy. Check style, if you have more than one developer, then definitely add it, because your code will look like code developed by one person, and everyone will understand it, and everyone will be on the same page. Copy-paste detector, again, if more than one developer, yes, because you will not copy-paste it. Infer, try it. It's quite smart, but it takes time to analyze, but at least during development, sometimes run it and check it, see what you may find with it. PMD and find bug, yeah, if you are quality obsessed, definitely also try it. You will achieve the biggest, better performance and better crash-free and bug-free app if you enable them wisely, and actually many of them, not just one. For Kotliners, there is a detect, which is also quite popular, and Lint is also going to have Kotlin support very soon. And if it is still not enough for you, there are many of them. There is even an article on Wikipedia about possible quality tools. How it is better to use it? There is kind of recipe which we use. So always use a pull request and run checks on every pull request. So you know that everything is stable in a pull request, and use commit status publisher, which means that every commit run on CI. It's actually quite common name, commit status publisher, and that you in your GitHub repository or Bitbucket repository will see a green check, which means every test passed and everything is all right. Otherwise, you will see a red cross, which means something failed. What we did for the first time, we tried to add all checks and all tools, and we wanted to make like a perfect application with everything, but it was a big mistake. It's really hard to maintain all these rules because some of them are not relevant. Some of them are quite hard, and build time is really affected by adding this. It's not actually build time, but check time, because there is a task called check, which you may call to run all the checks you have. And it's not wise to add all of them because it's really hard. But on some projects, it may be a case. But we decided to just check some of them, and it depends on the projects which we are going to develop, because we are outsourced also company, and we develop many projects at the same time. And if you have warning or error, it doesn't mean that you have a bug in your code. It just means that some code analysis tool thinks that there is a bug. So think about it, analyze it, and if it is a bug, fix it. If not, just add exception, and that's it. So what is outcome of all of this huge pack of tools? We have a better app quality, performance, and readability. Your team should be ready for it. You should see the benefits of using all these tools, because otherwise it's quite hard to integrate, but later it's quite easy to maintain. Extra effort for the first time, it's what I just said. So for the first time, you need to really spend time on it. And run all these quality checks before making a comment, because you don't need to run it on every build, because it doesn't make any sense. You just change it one line, you check it. You just change it one line, you check it. No, you run it once, you see. And during the development of the projects, you can actually foresee where you have issues. And you actually can understand, OK, this code will contain issue, and you will write it another way. And that's why as longer you have all these checks in your projects, less issues you will have. And max profit, again, may be achieved with continuous integration. Next section is about dev tools. It's about developer tools. It's tools which actually help you to also foresee some issues, try to detect them before you go live during the development process. And what is common for all these developer tools? They should be debug only, of course, because you don't want real users to see some logs or whatever you have in your developer tools. It should be standalone. It should be something you can easily remove or put if you want to put them back. Because, for instance, for release, you should remove it. So just by one variable, you can disable everything. It should be scalable, because later you may have to add more or remove some of them. And it should be useful. Yeah, it's I think, the most important one. You don't need to add them because you want to do something. Again, anyway, it requires some time to check, to see, to play with it. So it should be useful. The first one is Stetho. I think it's also quite common. How many people here know about Stetho and use it? OK, good. Yeah. This tool, actually, it's like a debug bridge in a browser. So what you can do with Stetho, you just add it in your project, and you can see in your browser, actually in Chrome, network inspection. So you may see all the API calls are going from application. You also may see shared preference, what you have in your shared preference stored. You also may see view hierarchy. So it's something you usually have in Android Studio, or which IDE you use. I think no one actually uses another IDE for now. But you may send version to someone, the bug one, and just in browser, you can see all this activity. And also one of the most useful thing, it's database inspection. So it's just in your browser. This is how it looks. It has few tabs, and for instance, this one is network inspection. How to add it? As I said, it's quite obvious. You just add it in your application, and if you want to have network inspection, you add to your HTTP client Stetho interceptor. You can also add support to raw HTTP connection, HTTP URL connection if you use them. It's not trivial. There are many answers, but I think most of now currently is using HTTP client. Chuck, another tool to access network activity is just this library. You add it to your project, and you will have ability to see through the notification all the logs of your network activity. And again, there is nothing special. You just add one interceptor to HTTP client, and you see it. Leak canary. It's also, I think, very common. Almost, I don't know, we use it in every project. How many guys know about leak canary? Oh, yeah, it's nice. It's nice, very simple tool. It's really simple, it's tiny, but it helps a lot. It tries to find leaked resources you have, activities or context or whatever, and shows notification if you have something. Sometimes you will see like a pop-up showing your app is freezing. We are trying to dump memory and check for leaks, and later you will see notification if something actually is leaked. And as all of these tools, it's super easy to install. It's just one line in your application. Links, another tool to access Logcat in application. Again, you don't need to send something. If you print some useful information in Logcat, you can add this library, and it has activity which actually may display logs from your application. It supports text filtering, it supports filtering by log level, log sharing, and it may be appearing by shaking if you enable that option when you initialize this library. Sometimes it may be useful, sometimes it's not, but yeah, again, if you have something useful in logs, then definitely give it a try. Timber, this one is also quite useful, and it's supposed to be used to get rid of logs in production versions. It's simple log configuration which has embedded lint rules, which is quite good. If you will be still using the old Android, not old, but Android native login, then you will have an issue which lint will mention. And it's how you usually initialize it. So we have just debug tree, which just print everything, and we have crashlytic tree, which is our custom implementation. It's just a few lines, as far as I remember. And what it does, so everything which we print into a log, it goes to console in debug versions, but in release version, it goes directly to crashlytic. So we accumulate all these logs, which has error or warning, and we send them to crashlytics. And if you want to log, you just call it like a regular way. It's message, or it also supports formatting, so you may have formatted version. Logger. Another thing which is useful, it's how you can print nice logs. And it has Timber integration, so you may use Timber together with Logger. And your logs may look like this one. So if you want to add stack trace, if you want to add some another information to your log messages, you may add it with Logger. If you want to print JSON, you don't need to do some extra things. You just pass it to Logger, and it will print it for you. Crash reporting tool. This tool may be obvious, but it's worth mentioning. It should be added only in release version. You don't want to see millions of crashes which happen during the development when you forgot to disable something. You should always log errors and unexpected states. If you think that it should never happen, actually someday it will happen. And that's why add descriptive error messages, and you will analyze them later. And enable it on early stages, because when you share builds on early stages, you will be able to gather all these reports actually before they go live. So what we have by using all of these dev tools? Add as many dev tools as your project needs. As I said, they require some time to configure. They require some time to build the bug version. That's why it affects some aspects, and there are not only benefits, I would say. And extract them, if it is possible, to a separate library, so you can easily disable it, enable it, and modify it if you want, or even move to another project if you want to move it. And your developer settings should be easy maintainable. Why? Because you don't actually need to spend time on the settings itself, but you need to spend time on development. That's why it shouldn't take much time to develop these tools or support them. Application metrics. This section is about performance and how to measure the performance of some particular things or general performance. You always need to, not need to, but if you want, it may be useful to keep track of build time, of launch time, it should be launch time, and application size. Why you need this? Because maybe you added some library which affected some of these parameters, and later you decide it's not really useful, but I may have it. But apparently it affected your launch time of your application, which means that you don't actually need that, but it affects the application that much, so it's better actually to remove it. And with all these diagrams, you actually will be able to see this before you actually see this issue with performance or whatever. And if you have tests, then also add test coverage, so you will see how much your code is covered by tests. Tiny Dancer. This pretty simple and dumb, I would say, library, which helps you to see the actual frame rate of existing window. What it does is just show the FPS of current window. Usually, if you have some really big lags, you will notice it without any library. You will notice by just lagging the application or laggable scroll, but you may not notice some small performance issues like 50 FPS or 35 FPS. But with this library, you can raise concern before the issue. Hugo. The another one library, which is about measuring some methods. It's called Hugo. It's developed by Jake Wharton. What it does pretty simple things. It just logs the arguments and return values of method. And it logs the execution time. Here is the example. Imagine we have method called getName. It does something. Yeah, never do this in real project, of course. It's just for example. And just by adding this annotation, we will see in log the next. So we see the parameters we passed into a method, and we see the return values with the execution time, which is quite useful because what we usually do, we actually write a code which creates some variable temporary, which you need to subtract from actual time before returning the parameter. Then you need to store it to another variable and then to return. So it's a lot of boiler code, which is just for debug purposes. And that's why it's better use library if you have it. Another quite powerful library to measure performance called Android Dev Metrics. And what it does, it actually shows you the actual time system spent on calling your lifecycle callbacks. So you may actually see how much milliseconds it took to execute on create of your activity, or on resume, or on start. And if you have some issues, you may point actually them just checking all this huge, I don't know how to call it, list. And it's not only for measuring lifecycle callbacks, but also for measuring Dagger2 objects initialization. If you have huge objects, then you can also check how much time it takes. The another useful feature is method tracing. If you see that there is something wrong with one of the callback, you actually may schedule method tracing for next launch. And you will see that your onCreate actually took, for some reason, like in this example, 400 milliseconds. And you will have a stack trace just of your method, which is really useful. This is what I said. And it also counts FPF drops, which also does the Tiny Dancer, which I showed, but just in different way. It just shows the amount, the number of dropped frames. The last section is environment tools. It's helpers tools. It's tools to help developers to do things faster and better. And the first one is JSON to Podge. It's not Kotlin, but unfortunately, maybe there is already for Kotlin. I need to check that. How we have usually requirements. It's just a response from server. And we need to have a class. And usually what we do, we just create all these not local, but parameters inside some data structure, and our data structure looks like this. But with this website, which you see in the bottom, you may be able to create this just by running one button. The another thing is resource management. Resource management is quite important, especially if you develop multiple clients in same company, what you can do, you can store all of them, all resources in one storage and use it from different, for different platforms, sorry. You need to operate with ID, not with values, and you can automate the import if possible. And work with them as with generated files, but not as with real values, and do not modify them locally. The last thing I want to say, it's color naming. There is always problems to name that color. Actually, there are some things with strings. It's hard to name that, but unfortunately, I cannot solve this problem. But for this one, I have a solution. Imagine we have this color. There is a website. You can see it again in the bottom. And you just say, actually, these names are not just random names. There is a naming for almost every color, like official name. And for instance, this one is called Swiss coffee. Cool, why not use it? And another one, just, why not? This official name. So, yeah, that's it. Just to summarize, all given above tools are designed to help, but not annoy. Why I am saying that? Because it's really hard to start with that. You will not get the benefits when you start. You will get them later on a long term. But once you see them, you will definitely use all of them. Add only tools you really need. Don't add everything you have, because it's quite also tough for compiler to build all the things. And no warnings doesn't mean that you don't have bugs. It just means that there is no bug in your projects which may be detected by some of the tools, but not more. Be patient. It may take time longer for the first time. Yeah, that's it from my side.
Thank you.